Okay, so 4.7 inverse trig functions. Okay, so inverse trig functions, we're talking about inverse trig functions. So let's say that I have a function that says y is equal to sine x. Okay, so let's look at this function. This function has a graph that looks like this. Okay, so this is y is equal to sine x. Now, earlier, way back when we, in the P section, we talked about inverse functions. And we said in inverse functions, well, how do we find an inverse function? Do you remember? We just switch the x's and the y's, right? And you solve for it, right? So if I had a function that looked like this, okay, then I would go ahead and switch the x's and the y's. Then I would solve for y, and that would be the inverse function. Okay. One of the things we talked about during the inverse functions then is that in order to have an inverse function, the function had to be a one-to-one function. Okay. You remember talking about one-to-one functions? It's a function that passes not only the vertical line test, but also has to pass the vertical line, the horizontal line test, right? So the vertical line test and the horizontal test, you can only have one for each one of them, okay? Just like this function right here, right? It passes the vertical line test. What about the horizontal line test? It does not. So in theory, I can't have an inverse function, right? Because it does not pass, it's not a one-to-one function, it does not pass the horizontal line test, okay? So to get by this detail, this little detail, the mathematicians decided to do something, not necessarily cheat, but what they decided to do is, okay, we're gonna make an inverse function of sine, but we're gonna use a domain where it passes the vertical and the horizontal line tests, okay? So basically what they did was they took this part, okay, this part of the sine curve from pi over 2, negative pi over 2, so this would be -1, this would, I'll just cut that off. So we're just going to use this part, and we're going to call it the inverse sine, the inverse function, because now it passes the vertical line test and it passes the horizontal line test. Okay, so the initial function is y is equal to sine x with a domain of what? What is my domain? It is from here to here, right? So it's going to be, this is my domain. What's my range? -1 to 1, right? Range is -1 to 1, correct? And so this is the function that I'm looking at. I'm talking about y equals sine x, but a specific domain from -pi and a half, negative pi over 2 to pi over 2. We're talking about just this domain. Okay. So in this, now we're going to go ahead and we're going to find the inverse function. To find the inverse function, I swap the x's and the y's, right? And I'm going to call this the arc sine of x. Arc sine of x. So it is the angle which gives me this value. So arc sine of 1 would be equal to what? What is the angle which gives me this value. Pi over 2, right? 90 degrees, right? 90 degrees is what gives me sine is equal to 1, right? What is the arc sine of 1 over root 2? What is the angle which gives me this value? What angle of sine gives me this value?
60.
No. What is it? Pi over 4, right? 45, sine of 45, 1 over root 2. Root 2 over 2. Did you guys already forget your unit circle? Man, I stopped giving you the quiz and you forget already? So this is pi over 4, right? Pi over 4, correct?
Oh, yeah.
And now let's look at the, remember the unit circle? There was another angle which gave me this. What is it?
What was that question?
We were busy getting packets.
Okay, so there is another angle that gives me a sine value of 1 over root 2 in your unit circle that is not pi over 4. What's the other one? Correct.
5 pi over 4.
3 pi over 4. 3 pi over 4, right? But actually, this does not work. Because we had agreed that we're going from negative pi over 2 to pi over 2. Does that make sense? You see why? Even though, yes, sine 3 pi over 4 is 1 over root 2, it is not a value of the arc sine. Because the arc sine here, now the domain is going, we just swapped the domain and the range because we swapped x's and y's, right? To find an inverse function. So the range is going to be equal to, the range is this guy here, right? Because it was the domain before. Now it is the range. The domain is from here to here. Okay, so in other words, I cannot have 3 pi over 4 as my y value. Okay. Now, another thing that we talked about is, let me draw this a little. Because pi over 2 is actually what, about 1.5, correct? So it should be over here. I can do better than this. Like that. Okay, so this is negative pi over 2. Okay, right? So this is the original y is equal to sine. Now since we are now going the arc sine, okay, we're going to do the inverse function. Remember, we swapped the x and the y's, and the graphical way to do that was to reflect it across y is equal to x. Remember that? Okay, so we're going to go y over x. Y is equal to x, I'm sorry. This is y is equal to x, and we're going to reflect this across this. So it's going to look like what? Like that. Okay. So what is this value here? This value is negative pi over 2 to this value here is pi over 2. This value here is going to be 1. This value here is going to be negative. Fairly complicated. This is fairly complicated. Okay? The mantra that you guys need to remember is when we talk about inverse trig function is the angle which gives me the value of. The angle which gives me the value of. The result is always going to be an angle. Okay? So the result of an inverse function It's always going to be an angle. So if so let's say that I said, what is the arc cosine of 1 over root 2? What is the angle which gives me this value?
45.
45. Again, it's the same thing, right? Pi over 4. Right? Is it pi over 4? What is the angle that gives me this value of cosine? What?
30.
30, which is pi over 6. Okay. What is the angle that gives me this value of tangent?
45.
Pi over 4. Right? Okay, what about
60.
everybody get that? Pi over 3, right? Because tangent pi over 3 tangent of 60 is root 3 over 1, right? Root 3 over 1. Right? Okay. Okay, so where are we at? We are. Okay, so we did basically. So let's go ahead and look at page 378. There is a blue box there. Read the blue box. Any questions on that blue box? We good? Arc sine, domain. Okay, we talked about the domain and the range. We talked about that. Example number 1. We're almost there. We did let's just say we did A, B, and C. Let's do B. B. So example 1, arc sine of negative root 3 over 2. Okay, so what is the angle which gives me this value? 60, but it is negative, right? So it's minus pi over 3. Remember, our domain was what? Negative pi over 2 to pi over 2, correct? So this falls within the domain, right? So we're good here, okay? Okay, so let's now go ahead and go to D. Okay, so I have arc sine of sine pi over 9. What the heck? What's pi over 9? We never learned a pi over 9. Pi over 9 is 15 degrees, by the way, right? No. Was it? Yeah, it's 15 degrees. No, it's 20 degrees. I'm sorry, 20 degrees. 20 degrees, right? It's 20 degrees. So we never learned sine 20, right? I don't know what it is. All right. So let's say that sine of pi over 9 is x. We'll call it x. So the arc sine of that would be what? Again, it's the value, the angle which gives me that value. So it's pi over 9. Right? So this is actually just pi over 9. Okay. So that was kind of interesting. And then we have the next one, the last one. We have arc sine of 5 pi over 6. So can we do this the same way? Why not? it would be 5 pi over 6, right?
That's too big.
Aha!
Aha.
It's too big, right? This is outside of the domain, right? It's greater than pi over 2. So this does not work. But I do know this value. What is this value?
It's just
Sine of 150.
yes.
So what would this be?
Pi over 6.
So this would be 1/2, wouldn't it? Is this value 1/2?
Yeah.
So this is basically the arc sine of 1/2. So now it is again, it is the angle which gives me this value. But I'm going to be in the first quadrant now, right?
Yeah.
So it has to be, like you said, pi over 6. Right? So this is going to be equal to pi over 6. So you see how that works. Here, you can't be 5 pi over 6, obviously, because it's not in the domain. Okay. Okay. Example number 2. I'll let you do that at home. Use your calculator. Make sure you're in radian mode. Make sure you know how to do that. That's example number 2. Inverse cosine and tangent. Let's do inverse cosine. Inverse cosine is similar to, well, arc cosine is similar to arc sine, okay? Similar to arc sine. Cosine graph looks like this, right? But again, we're going to have to cut off a certain portion that falls within, that satisfies the vertical and the horizontal line test. So in this one, they decided to go like this and this. They decided to keep this part here, okay? So let's go ahead and blow that up. Okay, so the original graph is y is equal to cosine x between the domain is 0 and pi, range is -1 to 1. So if I swap the x's and the y's, I get x is equal to cosine y, y is equal to the arc cosine of x. What's my domain now? -1 to 1. Range is this guy here, 0 to pi. Okay. And again, we're going to flip this across, right? Flip this across, y is equal to x. Okay. So I flip this graph, so if I flip this point, which is 0 and 1, now it becomes 1 and 0, right? We flip over to here, 1 and 0, right? This guy flips over to up here, pi over 2, correct? Like that. Can you see that? Because this guy over here was pi 0, now it becomes 0 pi. So it's going to be up here, pi, I'm sorry, -1 over -1. Right, because it was, this is the point, right? Pi and -1, so it now becomes -1 and pi. So this here is the graph of arc cosine. Okay, fairly again, it's fairly complicated. And it's like, what the heck is he talking about? How does this make any sense? And you need to just kind of go through the homework and go through some of the problems. And you should be able to work it out. Okay, so that's on page 380 middle. There's a blue box, so read that. And you can see how this graph here is in the top of page 380 on the right-hand side, right? You can see that graph? The arc cosine. And then after the break, during the second half, we'll talk about arc tangent, okay? Okay, so we are good for the first.